Hi, Game Master Brian, and welcome to Step 8. Today we're going to introduce the concept of systems theory. And it's really simple. Here it is in a nutshell. Systems theory is a tool for managing complexity. You walk into a complex situation. If you apply the rules of systems theory, it will help you understand that complexity. And here we are going directly back to what I talked about when we first started this project. And that was, I was going to give you more information, another way of saying more complexity, with better tools of understanding. And that's exactly what systems theory is. It is a powerful tool for understanding complexity. All right, let's jump in. So I'm talking about systems theory. What the heck is a system? And the game defines a system this way: a process for understanding complex environments by counting for all the parts of a whole, followed by studying the relationship between these parts, relationships between these parts. All right, so examples of a system can be an ecological system, and we're going to talk about those. We're going to talk about ponds, things like that. It can be a biological function. We're going to talk about that in a moment. It can also be any form of human organization. If you start a club, if you want to talk about any form of government, if you work at a place of business, all of those can be better understood by applying the tenets of systems theory. Okay, let's first start by talking about all the various systems within the human body. We've got the skeletal system, the lymphatic system, respiratory system, muscular system, nervous system, digestive system, urinary system, endocrine system, cardiovascular system, and the all-time favorite, reproductive system. In each of those cases, we're not talking about just one thing. We're talking about multiple elements of the system all working together to create an outcome. Now, we use systems theory to understand complexities in nature, and as I said, we also use them to understand complexities in any type of human organization. Now, the science of ecology is particularly interesting to our discussion here because ecology was itself born out of the development of systems theory in the 60s. And so we start understanding a pond, which is a metaphor and an example we're going to use in just a moment, as a complex set of interacting parts. Now, I just introduced a new idea, and that's the word set. This is not a trick. It's exactly the same concept that you were taught in middle school and probably, hopefully, even grade school. The Venn diagram, that circle. So we're talking about systems are sets of elements. And when we talk about a set, just think in your brain, you're drawing a circle. Everything that goes in the system or set is inside the circle, and everything that's outside of the system or the set is outside the circle. It's no more tricky than that. So now here I've taken this opportunity to walk on water, because we know how powerful that has been in the past, to talk about systems. Now we look at this lake that's around me, and what do we see? We see two things. We see water and we see trees. Is that all that's going on? No, and in fact, you've already studied, hopefully in school, and you understand that a pond is in fact a complex system because it's a set of multiple interacting parts. So let's take a look at rule number 8 of the game. All systems must be built using the 3 steps of systems theory. Number 1, list all the parts of the system. Number 2, determine if the system is open or closed. And number 3, study the relationships between parts. So the number 1 item is list all the parts. Now, we talked a little bit about integrity in the past. We're going to talk more about it in a couple more steps. But I just want to emphasize that when we're listing all the parts of a system, we have to do all of the parts, not just the parts that we like. We can't say to ourselves, I don't like that part, so I'm not going to include it. It doesn't work that way. If your goal is to discover the truth in the moment, you must bring all the elements in the moment together to study them. If you leave parts out, you're just deluding yourself. You're wasting your time. Okay, so let's go back and look at our pond. We've got what? We've got water, fish, birds, insects, reptiles, plants. And if you've taken a course in ecology recently, you probably could add to that list. The next issue is our system open or closed? So I brought as an example here, most of us have probably seen a mason jar before. Made out of glass, right? And we know that the mason jar concept also includes a screw-on lid, right? And then this item here, you'll notice it has a rubber element to the bottom side. And the idea is that we put these two items together, and then we put it on here, and we screw it down tight, and that screwing action has pressed that rubber seal solidly into the glass. We now have a closed system. There ain't nothing getting in or out of this mason jar. If we want to have an open system, this mason jar is now open. Things can go in, things can go out. There's nothing limiting it. It's no more difficult a concept than that. Now, let's go back to our pond. Is our pond open, like the mason jar with the lid off, or is it closed, like our mason jar with the lid on, screwed on tightly? Well, let's ask the question. Let's think about all those elements of the pond that we listed. I'm going to use 4 of them: water, fish, insects, and plants. Where did those things come from? Now you think about a pond. A pond has got a lot of surface area. And whenever there's surface area on water, you can guarantee there's going to be some element of evaporation. So if the water in the pond is evaporating, and some of it's going to seep into the ground, what is replacing it? Where does it come from? Well, it comes from rain. There might be 1 or more streams or creeks flowing into the pond. There may be an underground spring that's pushing water up into the pond. However it's happening, there's water that's entering that pond all the time because we know intellectually that there's water that's evaporating. What about the fish? Well, again, you know from science class that birds and animals can get fish eggs attached to them, and they can travel from one pond to the next. And that's how species of fish are transferred normally in the wild. Insects can fly from outside the pond's environment into the pond environment, and that same insect can then leave. Plants, again, either on the bodies of an animal or seeds. There are many seeds that actually float through the air, again, coming from the outside in to our pond. So we have to conclude at the end of our analysis that our pond is in fact open. Now, the third element. Now it's time to do the heavy lifting, which is to observe all the elements that we've listed in our pond and look at the way that those elements interact. You know, there's food chain issues, there's open versus closed issues in terms of things coming in and out of the pond. Ponds are very, very busy places, but you don't come to that understanding of how busy it is until you've applied the process of systems theory to it, and you start to having a more sophisticated understanding of a complex system. Now, and here's another question. What happens when a new species, and sometimes they're considered invasive species, enters into our open ecosystem? Now, here's a good example. This is called an Asian carp, and they are not germane to the Lake Michigan, the Great Lakes in the Midwest, but they're there. And as you can see by the photograph, they're there in a big number, and they're causing great disruption. And it's not just food chain disruption kind of thing. Those things get agitated by the sound of a boat's motor, and they start to flip up out of the water. And so you literally have a situation where you're driving your boat along, and next thing you know, you got a fish in your face. So that's our introduction to systems theory, and here's our prompt for the essay. I want you to describe a natural system. Now again, pick something that you know about. Maybe you've studied it, Maybe you're going to pick a sports team, or a sport. Make it easy, something that you know about. And what I want you to do is I want you to apply the 3 steps of systems theory to your system and talk about it from that perspective. Just, 3 short paragraphs, maybe only a couple sentences long each. But I want you to tell me about the first step of collecting the data or collecting the set, and go right down the list and answer your essay that way. Don't get stressed about this. Remember, there's no test on Friday. And if you feel unsure on your feet on this subject, we're going to spend, I think, the next 9 steps just talking about systems theory. So don't stress about it. You're going to pick it up along the way. And we'll see you tomorrow at Step 10.